Hi everyone, and welcome to this morning's webinar. I think we've got a really interesting presentation for you today. So joining me is Kevin Askew from GoPrint 3D, or what's now called Additive-X. They are a reseller of MarkForged printers, and I think I've seen his presentation. Actually, it gives us a fantastic overview of the technology. Where we've seen sort of some really interesting uses for this, where we've produced fantastically strong parts and really accurate parts as well. But Kevin will kind of give a bit of more information about. For those who don't know, I'm going to kind of hand over to Roger in a second, who can give an overview of the SAM project. I believe if you've got any questions or anything, there should be like a little place for asking questions on your screen, and I can sort of perhaps pick those up at the end for a bit of Q&A at the end of this, or or we can take them offline if it's something that you want to discuss confidentially. So without further ado, I'll kind of hand over to Roger. But just one more thing: this is the first, we've just moved over to this GoToWebinar software. So forgive us if there's any little kind of glitches along the way, and we've dropped Kevin, a bit of a bombshell for Kevin, saying, oh, by the way, we're now using this. So please give us a little bit of latitude. So without further ado, I'll change to Roger.
Thanks, Carl. I'm just open the presentation there, and share that. So hopefully you can now see the screen. I'm just going to turn the video, my webcam off so that it maximizes. So there you go. So I'm Roger O'Brien. I'm the head of AMAP, and I'm the technical lead on the Sustainable Advanced Manufacturing project. Just going to give you a short introduction to the Sustainable Advanced Manufacturing project, to tell you how that might be able to benefit you with the sort of subject area that we're talking about today. So, excuse me as well, I'm running off an iPad and on PDF rather than PowerPoint, because there were a few strange things happening yesterday with fonts when we were trying things out. So it's all a bit of a learning curve to us on GoToWebinar. So the SAM project is now in its second phase. It's actually started out about 3 years ago, and it runs until June 2023. It's a £10.9 million ERDF project, which is aiming to support manufacturers, particularly SMEs in the northeast area. And that's all around introduction of products and process development and new technology for those manufacturing SMEs that are eligible and in scope in the region. The project's funded by ERDF, which might be strange seeing as we've now Brexited, but that continues until June 2023. And there's £5.7 million funding coming from Europe, and that's matched by the university and leveraged match from industry. The project has roughly around £2 million of grants left to support capital, product validation and tooling, and you can bid in for a number of those areas. That grant pot's back open, and that can include, and has already included, people investing in the sort of technologies that we're talking about today around additive manufacturing. So it needs to be something that's new and innovative to the business, but we'll explain the grant pot as we come along. So I'm not going to dwell too long on this slide, because I know you're interested really in the additive manufacturing and learning about the fibre reinforcement of 3D printing. So just to show that we're part of the University of Sunderland, we actually sit within the Faculty of Technology, but we can draw on the wider wider area of the university to support the project as required. So the SAM offering is split into three or four areas really. It's actually five, but the fifth area is really funding for the equipment that we can bring leverage to support the SMEs. So we can provide technical support, which ranges from 12 hours all the way to 15 days of fully funded technical support on a project related to the product or process development, best practice, upskilling, and you'll see some of the areas that we cover shortly. That's fully funded, so it's at no cost to the SME. Some of the projects that we get involved with are a bit longer term than that, so that can be on more of a research basis, and they're a little bit more open-ended, but again, they can be fully funded, and they can also be collaborative with other companies working together. As I mentioned, we've funded a lot of equipment, so we've set up 5 micro factories, and we've spent around about £1 million to date on state-of-the-art equipment, including a large investment in additive manufacturing. And those factories are there for the SMEs to make use of and visit and learn about the technologies. Because again, sometimes learning about the technologies helps avoid a poor investment decision, which we've had a number of SMEs come in thinking that they want to do it to invest in a particular area. They've come in, learned some more about a particular area or subject and found out, no, that's not what they needed to do, and actually changed their strategy, so avoided them making a poor investment or an incorrect investment, and then they've been able to focus on the area that was right for them. So our 5 micro factories, we've got a production factory which has got robotics, automation, machine tools, everything you expect to find in a factory. A prototype and innovation factory where we have a lot of our additive manufacturing equipment. Digital factory, which includes all of our CAD, CAM, augmented and virtual reality. An improvement factory, which is around control, Industry 4, hydraulics and pneumatics. And then we've also got a metrology factory where we have a range of measurement equipment for inspection and quality control. So, and the final area is grants. Everybody's always interested in grants. The grants are about uplifting the state of the SMEs, and they're eligible up to £50,000 subject to match funding. So they have to be match funded by the SME. We'll explain a little bit more about grants as well and the process that you go through. So we've got a team. We'll not dwell too much on the team because that's really not the important side of things, but you can see we cover a range of areas, and we can draw in to support that team as well. So supply chain, process improvement, design, digital, Industry 4. All of these sort of areas are all covered by our technical team. Just to give you some idea of the sort of projects that we're covering and the areas that we cover, you can see that a lot of these are interlinked or overlapped. So additive manufacturing's in there that we're here to talk about at the bottom of the slide, but also the CAD to get the data in for your additive manufacturing models. We thought that was designed for manufacture. Metrology and reverse engineering allows us to inspect products even after they've been made on an additive manufacturing process. Just because it's additive manufacturing doesn't mean it's 100% correct, and you do get some occasional problems with the process. So the metrology allows you to inspect that. Likewise, reverse engineering allows you to take a product, create a CAD model, and then create, if you need be, a 3D print from it. So that's useful in the case of spares, certainly for older products that are no longer available. And that's everything else is linked there through. So AR, VR, we've got a large AR, VR lab. Discrete event simulation, where we can do process modeling. And that can also be output into AR and VR through to more of the traditional engineering on condition-based monitoring, advanced maintenance, electronics, robotics automation. All of these sort of things are all part of the SAM project. So if the company's interested, the first step is via the SAM website, which has just been relaunched. We've got a new SAM website that's gone live. On there is the registration form. You submit your registration form, and that goes to the admin team. They do some eligibility checks. Providing you're eligible for the project, then somebody from the admin team will come out and do an initial review with yourselves, and then start the engagement. And that can be in the research, the technical area, access to the factories, and providing you've had some support, then access into the grant program as well. So again, there's some separate forms that you have to fill in for grants, but there's lots of form filling in the early stages. But hopefully we keep it as streamlined as possible, so it's not too arduous task to engage in. So in terms of what we're going to say today, in terms of the SAM project, that's just a little bit of an overview, because we're really here to talk around the additive manufacturing with the fibre reinforcement. So I'm going to hand back. If anyone's got any questions, we'll be doing questions and answers at the end, although I'm happy to take some now. But I shall hand back to Carl, and then we can introduce.
Okay, thanks, Roger, for the overview. We're going to hand over to Kevin now to go through his presentation.
Good morning, everyone. Carl, could you just check that you can hear me okay?
Yes.
Good. Morning, everyone. Just to go through some of the points that Carl mentioned beforehand. So the company I work for is called Additive-X Limited. We changed our company name at the beginning of December from GoPrint 3D. So our websites are still showing as GoPrint 3D. We're busy transferring everything over for search engine optimization, so we don't lose Google rankings, over to the additive-x.com websites, which should be going live at the end of January or the beginning of February. So just in case you do decide to look for Additive-X on the internet, there's no website there. We are still on the web as a presence as GoPrint 3D. So we're here today to discuss composite 3D printing using continuous fibres with the MarkForged 3D printers. Just bear with me, sorry, it's not flicking around. So yeah, sorry, to discuss MarkForged continuous composite 3D printers. The overview will look at the operating systems from MarkForged, as well as the benefits it can bring to companies and the parts it can replace, looking at the cost of ownership, a little bit about return on investment, and looking at some of the case studies. The case studies are both high-reaching and also kind of low-hanging fruit case studies to appeal to a number of people, because when you speak to manufacturers, they all like the multi-million pounds worth of saving case studies, but often the ROI on a £16,000 machine can be achieved quite easily through very simple steps within a business, looking at different applications within the company's online walks or working with the likes of the SAM project. So composite 3D printing and materials is widely advertised and promoted out in the marketplace. Is one of the major breakthroughs. It is opening applications wider for 3D printing, almost moving it from the prototype arena and the perception that it's for weaker parts, and in some cases people perceive 3D printing as printing toys. It's certainly moved a long way from that, and MarkForged are one of the drivers behind that. So there are companies working in PEEK, PEC, Ultem, so very high-grade polymers, but MarkForged are really driving the movement on continuous fibre printing and continuous carbon composite printing, really opening up the possibilities for customers adopting the technology and reducing overall weight of parts due to the infill structures, and then minimizing the material used. Anybody who is well versed with additive manufacturing will understand the less material that we use on parts, the quicker they print and the cost comes down, which is the flip reverse to subtractive. So if we can minimize part design, if we can start taking away areas of parts that generally don't need to be there and don't affect the overall structural strength or the aesthetics of that part, then it's ideal for additive manufacturing as well. So what is composite additive manufacturing? Composite is a term which is liberally, in my opinion, thrown around within the additive market. There are many companies claiming and saying that they do printing composite materials, or their machines are called composite printers. Really what they're doing is their main build matrix is a composite material. So it's a plastic or a nylon infused with carbon or glass filled fibres. Some examples of these out in the marketplace are Colourfab CF20, which is a PLA matrix material, so very low heat deflection temperature, which is infused with a short strand fibre inside it. We then have your nylons, your PA12s, your PA6s, your blended nylons, your PA6s and 66, which are short strand chopped carbon fibres embedded within the nylon part. Peak with short strand fibres is now out, and people are using on certain machines. I don't think it'll be too long before the likes of MarkForged jump into that market. I have no idea of their product roadmap, but looking at where they sell machines to and the area in which they kind of play and operate, then it wouldn't be any surprise that they start looking at higher temperature reinforced materials at some point, because there are other companies out there that are investigating it. Over the last year, MarkForged have also launched flame retardant onyx material. So again, that's a material with short strand fibre in. It's a nylon with short strand fibre in, with a V0 rating if printed over 3 mil thick. And also there are ESD composite materials out there in the marketplace. So there are lots of companies, as I said, advertising the fact that they can print in composites, but we need to just take a step back and look at what actually is the composite infused into, what is the main build matrix or material that composite fibres or short strand fibres are going into. So the range of machines on the market, some are open source, some use proprietary materials. So we do have companies out there that just make composite materials. For example, 3DX Tech sell a full range of composite materials which can be used on Ultimaker 3D printers, but you do need to buy a special print core on the Ultimakers, costing around £290 at the moment, whereas other machines such as MarkForged are actually engineered and built for the composite market, for the abrasive nature of that material, and can print far better. Not being biased, I do sell a range of 3D printers, but when we look at the plastic extrusion or polymer extrusion market, the quality of prints we get from the MarkForged 3D printers far exceed anything from any other manufacturer. Even when we look at trade shows and we look at some other polymer extrusion machines and we compare them to the quality we're getting from the MarkForged machines, they're unsurpassed in terms of extrusion technology at the moment. I would say they are absolutely top of the tree for quality part finishing using the onyx material. So as I mentioned, all of these printers and manufacturers claim to print in composite materials. MarkForged are the world leader of the movement that takes this one step further by introducing continuous composite materials from a second print head into the part. So their onyx material, which is their black material, is the main filament in their printers. They do a white nylon, which we can use on their Mark II, which is their top of the range desktop machine, and the X7, which is their top of the range industrial unit. But that, if I'm looking at a split, it's probably about a 95% sales of onyx material, a 5% split for white nylon. People tend to use the white nylon if they've got any conductivity issues with having the carbon fibre in the onyx material, or if they've got any issues and want to see swarf coming off the parts for post machining, etc., then they like to see the white material in that. But the onyx material is the main one we'll discuss today, and it can be laid with short strand fibres inside it, but then you, as the main matrix material, but then you can add in continuous fibres, creating parts for high-end use and real high strength applications. And MarkForged have patented and termed this technology as CFF, so Composite Filament Fabrication. You'll see a lot of these acronyms out in the marketplace. So FFF and FDM are exactly the same technology, just Stratasys have patented the FDM name, which is Fused Deposition Modeling, and the rest of the market call theirs Fused Filament Fabrication. As I say, MarkForged have taken that one step further and are the leader of putting in these continuous composite strands, which are for composite filament fabrication, which is their technology. So if you are thinking about how that works, if you go back to reinforced concrete, it works very much in the same way. So you'll see two pictures on your screen. One which is the reinforced concrete with the steel wires running through it. The second one is the MarkForged material. So you will see the continuous black matrix material, which is the outer shell of the part and the infill of the part, and then we can add in those continuous fibres rooted throughout the part. And I'll touch upon that in a bit on the Eiger software about how those are routed and how you can control those particular routing of the fibres around the part. But it's just a nice analogy to look at it as in reinforced concrete. So MarkForged materials and software. So they've developed a complete system. It's not just the printer. So they make their own materials, both the continuous composite and the matrix material, and MarkForged develop their own software. So when they are looking at a complete package, they are in control from basically cradle to grave in terms of their ecosystem. They understand their materials because they make them. They understand their printers, and their software is obviously the engine behind all of that, looking at the fibre routing and tool paths of the continuous fibres, and also progressing further into how the materials can be laid and used. I'll touch upon the software a little bit further and how they are developing that in a short while. But the MarkForged printers range from desktop to industrial units. All of these are operated on the same software package, which is predominantly cloud-based. There is an offline or on-premise software package, but really they see the future of their software really being cloud-driven. For global sharing of files, global printing of parts, disrupting supply chains, etc., within their system. So the MarkForged software controls desktop and industrial printers, and just an interesting note, it also controls the Metal-X 3D printer as well. So with a click of a button, I can print a part in the onyx material for a form fit, and then I can absolutely just drop down menu, click Metal-X, click one between one of 6 metal materials, and then I can print that part in metal as well. I've got an example of some hybrid tooling which we've done some metal and composite printing on further in the presentation, so I hope that's of interest to some people. So continuous composite materials MarkForged have in their range are fiberglass, Kevlar, high strength, high temp fiberglass, which are referred to as HSHT in MarkForged terms, and then the carbon fibre. So when we're discussing with customers about applications, it's interesting to know how that part is being used. Does it require the strength of the carbon fibre? Does it require the impact resistancy of the Kevlar? Can we add in high strength, high temp fiberglass to give it a little bit more heat resistance? if it's being used for example, mouldings, or if it's being used for anything which require the heat resistance. The onyx material, just as a side note, goes up to about 140 to 145 degrees is a heat deflection temperature. And then we can add in the heat, the high strength, high temp fiberglass, which does add a little bit of a wall in between the inner part. So you've got the outer matrix, then the fibre, and then the inner part. It does create a little bit more resistance for heat to the inner of the part when printing in that material. The main matrix materials on the MarkForged I've already touched upon are the onyx, which is a PA6 nylon with short strand chopped carbon fibres. The onyx flame retardant material, V0 rated above 3 mil width. And then we've got the onyx ESD material as well, which is the electrostatic discharge. So talking about the complete system, as I've said, they've got a comprehensive portfolio of materials which they manufacture themselves. MarkForged do a lot of testing of parts and do have applications engineers based in the different regions, so EMEA, Oceania, Asia, etc. They do have applications engineers which their resellers, such as myself, can call upon, and we can ask for advice and support. So if my applications and tech specialists need any assistance, we would go to them and we would involve them in the conversation about particular parts. And they then have their technology is so easy to use, their software is so simple to use, and the printers are very easy to maintain and operate as well. Now, just going back to the last part there, I've been an innovation leader. MarkForged are developing software. A big barrier to entry within additive manufacturing is the fact that people want to know, will that part work like a machine part? So I'm sure people are aware that we can do finite element analysis on parts for subtractive manufacturing. That is very much more difficult in terms of additive, because there are so many different ways we can orientate the part. There are so many different infill geometries to that part as well. And then with the added fibre, continuous fibre tool paths within the MarkForged, that's even more difficult to predict in terms of where the strengthening is. So MarkForged are really pushing a piece of software, or developing a piece of software called Blacksmith. I haven't touched upon it too much in this presentation, but if you search online for MarkForged Blacksmith software, there's some public facing documents and some presentations all about that and how they're looking for that to work. I was just talking to Carl Gregg from the SAM project earlier about some software for FEA analysis, and it is being built into packages that MarkForged are discussing publicly as well. So I can see in future that it will absolutely get there. We will be able to drop a part into the analysis software. We'll be able to set the tool paths, and we will be able to see if that part will cope with stresses and strains of the manufacturing rigors that it is under. At the moment, it is done through education, it is done through people understanding the technology, and it is done from previous experiences of what has and what hasn't worked, along with very much some common sense, as you will see going through the presentation. So the composite printer range from MarkForged, there's 6 printers in the range, 7 if we include the Metal X, but obviously that's not composite. So we've got 3 desktop and 3 industrial. This slide is available to download from the tool deck, which I hope everyone's got access to. There are some PDFs there, a copy of this presentation, the materials data sheet, and also this composites printer comparison guide as well. So you'll see from there the 6 machines. Starts off with the Onyx 1. So we're looking at a printer that comes in at £3,995. So that does not use continuous fibres. It just uses the main build matrix, like many other 3D printers do for composite materials. But the finish is superb from it. As I've said earlier, by far the best finish we've seen from polymer extrusion units. We then step to the Onyx Pro and the Mark II. So the Onyx Pro can use continuous fiberglass, as you can see from the chart, and the Mark II can use all of the continuous fibers that MarkForged currently have in their range. Once we step up to the industrial series, bigger print bed, the X3 and the Onyx One are similar. They just use the Onyx material, with the advantage that the X3 can use the ESD material and the flame retardant material. The X5 is similar to the Onyx Pro, as in that it uses continuous fiberglass, and again can use this ESD and flame retardant material. And then the X7 is the top end of the MarkForged range, which is coming in at around 53,500 currently. That has a number of features built into it over the other machines. So as you can see, it can use all of their materials. It also has an in-process laser inspection scanner, so we can scan parts on the machines, and we can then look at how those parts are printed, the internal structures of those parts, if we're doing batch production and we need to check, or if we are just wanting to look at how the parts are laid down. A lot of universities use these for assessing the material capabilities of the machines and looking at how well it knits the infills together, etc. So it's got in-process laser inspection scanner, and it is their flagship machine, and any new materials that are brought out generally are aimed at the X7 and then work their way back down the chain. Some of those obviously don't, and I can see the X7 just being moved further, especially with the advent, as I've said, of the FEA analysis software that really will be aimed at the production units and industrial units, especially the X7 machines. Just to note, while we're on here, we've got some pictures of the MarkForged machines. You will see on the smaller unit on the screen that it's got some reels of composite, some circular reels of composite material sat in the printer. So where the material's loaded on the machines is that the continuous strand composite sits towards the left-hand side of the print bed as you're looking from the machine at the front, and that feeds through into a print head, which also has a cutter on it, so it can chop the fibers when it's finished printing. And the main build material, the onyx or the nylon material, are housed in dry boxes. On the desktop machines, they sit behind the unit. On the industrial machines, they sit in that cabinet underneath. So they're pelican cases, which are fully sealed and use desiccant inside them, just to keep any moisture away from the material before it's being printed. So yes, the main build material in a dry box. The composite material sits to the left-hand side of the machine. You will see at the right-hand side of the MarkForged, the desktop unit, that's just a spare reel of filament, just so it's handy for the user. I don't believe that's there on the new machines. It was never particularly used, but I don't think it's there on the newer generation of the desktop units. But just to kind of show you where the material sits in those particular machines. The printer is not heated, so the print bed is cold. I'll touch upon that a little bit further in the Eiger software as to why that is. And also the machine is not a heated chamber either. It just doesn't need it for printing the nylons. The parts are dimensionally stable as it is anyway, and are dimensionally accurate to approximately 125 microns on the XY axis, depending on the geometry of the part. So how does the machine work? So first of all, everything is driven by CAD software. So we would export the STL files from whichever software packaging you're using. We would then drop that into the Eiger software, which is for slicing and reinforcing the parts. And then we would then print the part. So on the slice and reinforce section in the center, you'll be able to see the fiber track around the outside in yellow. So that would signify that we're using Kevlar, and that we've got two continuous strands of fiberglass running through that part. And then you can see on the print side, that's actually a photograph of a printed part. You can see how that Kevlar looks once it's printed inside of that particular part. So the materials data sheet. As I've said, that's available for download in the handout section of the webinar. You will see the flexural stress on the left-hand side of the nylon and onyx material compared to ABS, which is a popular 3D printing material. And you'll see the megapascals on there on the gradient. On the right-hand side, you will see how that changes with the addition of carbon fibre, high strength, high temp fiberglass, the fiberglass and the Kevlar. So you can see obviously the scale of the megapascals massively increases. And we've also got in there as a comparison how the carbon fibre and the high strength, high temp fiberglass compare to 6061 aluminium on there as well, and then just how that compares to onyx material by itself, which will then correlate to the graph on the left-hand side of your screen. So I hope that shows some indication of how strong the parts can actually be achieved. Obviously, we can vary that depending on how much fibre we place in the parts as well. So that's controlled mostly by the user. So this is, let's hope this works. A video just showing a little bit of an Instron test on the MarkForged units. So you can see this part's been printed in the carbon fibre. And it's just to show the actual pounds it can achieve on the Instron. So it broke at 22,100 pounds on that particular part, which is a nice little video of that. So I'm going to delve into the Eiger software. Please forgive me for a second while I switch in and out of the different software packages. I want to run through the Eiger software in some detail with you, and hopefully it will assist. So just bear with me 1 second. Carl, can you just confirm you can see the Eiger software there, please?
Yes, yep, can do.
Yeah, lovely, thank you. So this is the main screen for the Eiger software. So when you log in, you will see a library of all of the parts that you've uploaded. I can't go into the library because we do have some sensitive parts in there, but as you will see that we can import the STL, and then we would either select that from our computer. I'll just see if I can just do one for you while I'm in. So that's imported that STL, lovely for me now. There we go, that's in, and this is the part that we'll be able to see here. So I'm just going to look at this part with you while we run through everything. So we'll see we've got a couple of sorry, yeah?
Kevin, the screen's not moving. Are you loading? Have you loaded the part up or something?
Yes, I have, yeah.
Because it's still on like the right. It's updated.
Has it updated?
Yes.
Right. Okay. Cool. So you can see the file 005919. Yes.
Yep.
Top corner. Yeah. Okay. Thank you. So you'll see from the different settings we've got here, we've got the general setting, which we can choose our materials depending on what machine we have. So for example, the Mark II cannot print in the Onyx FR and the Onyx ESD, but it can print absolutely in the Onyx and the white nylon. We've then got our reinforcement material here as well. So if I want to reinforce the part, I can look at the fiberglass, the carbon fibre, the Kevlar and the high strength, high temp fiberglass. And then I've got my machines here. So if I've got the industrial series or the metal series, I can switch between my print beds, etc. on those particular machines there. We've then got our settings on here, which we can choose between the different layer heights. It's important to mention if we are using continuous fibre, the layer height of the Onyx material is dictated by the layer height of the continuous fibre material. So for example, I couldn't print at 200 microns if I'm using something like carbon fibre. So if I go back into this and then pick carbon fibre and I just save that. Then my layer heights have been cancelled out because I have to print at the 125 microns, which is the Z height of the carbon fibre material.
Kevin,
yeah.
the screen isn't updating. It's still just on a static image for me.
Right. Okay. So you see that?
Yeah. That's moving now.
That's moving. Okay. No problems. So you can see there in the top right hand side that the layer height is 125 micron. I say that's fixed now because I've changed the I've added in the carbon fibre, which height is 125 micron in there. In terms of other settings, I can change the support angles if I want to. We do find that the MarkForged support material, it's laid in the concertina effect, removes very, very nicely from the part, very easily, and we tend not to change the support angles too much, but that's obviously part and geometry dependent. And then we have features such as raise part, expand features, use brim, etc. You'll see these little question marks pop up on the side as I hover over them. The Eiger software is very good because it will explain as you move through. If you are looking to change the part, it will show you how that part can be amended by raising it off the print bed and why you would raise that off, and by how much it raises it from the print bed as well. We would use this if we've got detail underneath the part and we don't want a very, very thin support structure. We would raise it so it's easier to remove. And things like brim we would use on taller, thinner parts just to give it some stability on the print bed as well on there. So looking at the infill, we've got a default triangular infill. MarkForged will always recommend this as the optimum infill structure. We can change this if we want, hexagonal, rectangle or solid. We have used solid quite a few times for customers who want to bulk up their parts for certain applications, but triangular infill is very strong and very good. It defaults to 37% infill density on the parts. Again, we can change that if we want, but MarkForged have spent years perfecting the right settings for their machines, and they have pretty much nailed them down. So we, again, internally tend not to move that around too much. The only one...
Kevin, can I interrupt? I've just checked with Roger, and this isn't moving for...
I'm not moving anything.
All right, but it's have you changed away from the settings screen? Because when you were talking about different infills and things, I was still on the... Yeah, that's just updated now. I wonder why.
Okay, so that's right. Every time I change screen, and I'll have to press the play button just to refresh it, I think.
Okay, it should be. Yeah. Have you got it on play, not pause? On the sharing screen.
Yeah, yes. Yeah, it's on play.
That's animated now. I can see it.
All right. Okay. Sorry, I must have clicked the wrong thing. It was showing as the play button, but bizarrely it's now showing as the pause button. But anyway, so sorry about that, everyone.
It might be worth going back a few steps, because I think it was
right. Okay. So is that moving now freely?
Yeah, that's great. Thanks.
Right, sorry. Okay. Sorry, everyone. Sorry. Teething problems. So settings. Sorry about that. So yeah, you can see the 125 micron is grayed out now because that's the layer height of the carbon fibre. So that dictates the layer height of my onyx material. I can change the units if I want to, the scaling as well. And then, as I just mentioned, but I am sorry nobody could see, was I can raise the part of the print bed if I want, expand features or use the brim. As I was saying, the MarkForged Eiger software is very good because you can just click the question marks and it will tell you what that feature is for and why you should use it. So saying we raise the part of the print bed if the part has got detail underneath the flat surface. So if it's got some detail on it, it will add a very, very thin layer of support structure. We would raise that off the print bed just so the detail comes out better and the support structure is easier to remove. And then we have, again, beta features, which are well labeled. So if you want to use them, you can, but it will tell you it's beta and that it's at your own risk. But again, they are there for increasing the speeds of printing support structures and for printing infill structures, etc. So moving on to infill, you can see that the triangular infill there is set. As I was just saying, MarkForged have perfected their software, so we tend not to move around the infill structure too much. We do use solid infill sometimes for some customer requests, but very, very rarely do we start using hexagonal or rectangular. We would generally stick with a triangular infill. And then we've got the infill density of 37%, which we can move up and down. And the things we do move are the roof and floor layers. So it will tell you there that what your current roof and floor layers are. The reason we change that is if people want to add inserts into the parts, so for example, screw threads, etc. We would change that if people wanted to machine the parts slightly back to get a tolerance, a greater tolerance. We would add additional walls for them to machine back or sand into. And so that's why we would change the roof and floor layers, etc. on the part. When we're looking at reinforcement on the parts as well, we can then look at isotropic infill or concentric infill around the part. And again, I hope you can see that it's come up showing the concentric fibre rings. Does that work, Carl?
Yes.
Good, thank you. So it's showing you how those concentric fibre rings would be placed. And that's showing you, again, you'll be able to see it's saying 10 rings now, 3 rings, and then it should go up at 6 rings. So you will see this is where I change the number of concentric rings on the part. And then I can also change the fibre angles that are laid down during the printing process. So what you will find is that the Eiger software will automatically put 4 layers of onyx, then it will start to do your composite materials in however many layers you tell it to, and then it will cap it with 4 layers of onyx. So it almost encompasses, well, it does encompass the part in the fibres in this onyx material, but I can change the angles of the fibres around the part should we wish to. When we are looking at the isotropic infill, it does automatically change the fibre angles of the parts anyway between the different layers, just to give it that isotropic effect. Now, I do get it's not full isotropic, it's on the XY axis rather than the Z. So people do mention to us that it isn't true isotropic. We do get that, but it's close to isotropic as I'm going to get on plastic extrusion units for those. So if I just go back to my general settings, I'll go back to Kevlar because it's the easiest fibre to have a look at. If you just bear with me 1 second. So with this section, it is worth thinking about how the part is going to be used in application. So if the part is going to have forces coming across the Z-axis, so it's going to be coming from this angle in, then it's obviously the break or weak point is going to be round the section between the disc and the tall vertical tubing. So if there are going to be greater forces put on that, then that is going to be a weak point, and we've got to think about that, and we need to orientate the part around it. So for example, if it was that, we would tend to try and print any holes on the vertical because they are more dimensionally accurate. But this part, we would try to look at printing in this direction, especially if the angles are coming over here, again, because that's going to create strength as it stands in the orientation as it's going to be used. I'm just going to delve into the internal view in a second and show you how we add the fibres into that. Just checking, I'm still moving around, Carl. Can you still see that?
I do, yep.
Yep, okay, lovely, thank you. So you will see here that the software automatically puts the fibers in, which are the yellow sections here. It will always do it as a top and bottom I-beam configuration. You can change that, but as default, it will start with that I-beam methodology to make the part stronger. You can start to look at the visibility of that part, and you can scroll through the support structure, the walls, the roofs, the infills, etc. Now you will see it's not highlighting any composite material here. That's because there isn't any in the part. It just physically cannot fit composite into these small sections, which are the top and bottom of the part. And this is where we need to start to think about the different fibers that we can use. So I'm using Kevlar at the moment because it's nice and easy to show on the screen. It's a bit of a brighter color. So if I go to, let's start up at about 133 and move up. So you can see here, I'm just dragging it through the part. And what I'm doing is I'm saying this section here, when it would stand up in the application, in the orientation for application, is potentially a weak spot. So what I want to do is run my fibers along this area to give it some strength. Now, what I can do here is, you can see on my screen, I've got use fiber. So if I click that, I can then start to look at whether I want all of that to be added with fiber, or do I want to add it in stripes? Now, looking at the stripes, we can start to add the stripe count in there. It's set at 3, but I can raise that up to, as you can see, 49, and the number of layers of composite material that are in that stripe, which is currently set to 4. So if I change that to 5 stripes of 4 layers, if I just use concentric, so there I can switch between concentric and isotropic. If I do it around all walls, when it's talking about all walls, I can either do inner and outer shells only, or inner shells only. So it will just do around holes internally if you wanted to, or outer walls if you wanted to. But I'm just picking all walls at the moment, and then we'll increase that to 3 concentric rings, and I'm going to create that group. Now what you will see along the bottom is that it will start to create that fiber grouping, and you will see that appear on the screen now. Just wait till that runs through. So now you can see, if it was standing in the orientation that we would do for, that would be used for application, this no longer would be a weak spot, because we have continuous composite fibers running all the way through the part, from the base up to the cylindrical vertical part as well. So that's running all the way through with 3 concentric rings. And you can now see on my visibility chart that I can view the continuous fibers. So if I just select that, it will show you now how those fibers look inside that part. If I just want to look at support structures and where that is within my part, I can do. Obviously now it's running down the vertical shaft on there. And if I want to look at the part in its whole entirety, that's what it would look like. What also is interesting on the MarkForged Eiger software is that I can do a 2D view of the part. So if I've got particular areas of the part that I want to assess or look at how it's printing, I can do that. So you can see here, this is all onyx material. So I've got the white, which is the infill. I've got the purple, which is the support structure. And as you can see, the support is in that that concertina effect, as I mentioned earlier, very easy to remove. And you can see there, it's starting to go through the part layer by layer. Now, if I could zoom in, you can see I've got my walls set to 2. I mentioned before, if I did want to machine into that part, I could increase that wall thickness to 4, 6, 8, etc. And that would show in this view as well. So as we continue to step through the part, you will see as we go from that, I was talking about it encases the composite material in onyx. So we're starting to get to that encasing. So we've gone from an infill to almost a 35, a more solid section of onyx, because this is where we start to get the composite materials. And you can see now that conforms exactly with what I've asked it to do. 3 concentric fibre rings around the walls, and then you've got your infill in the middle, and then your support structure around the outside. And as I step through that, you'll see we're now out of that Kevlar banding, and we are just about to go into our next banding of Kevlar, which then you can see there. And then we can alter that if we want. We can start to move those fibres around. We can start to increase the fibre settings. We can add groupings, delete groupings, etc., and then get the part to the strength that you want it. I mentioned on a previous slide, the printer overview, that it wasn't a heated chamber or a heated print bed. MarkForged have a really nice feature, so they've got kinetic coupling on all of the print beds. What we can do is we can tell it, the printer, to pause after a certain layer height. So if we want to design a cavity into that part, and we then want to put in, let's say, for example, an RFID chip on there, we can do, and we can then go over and we can take the print bed out of the part. We're not messing around under a hot print head or anything. You take the print bed out, we would put the RFID chip in, making sure that it's flush with the current print surface. We can then return that part to the printer, or the print bed to the printer, press resume, and it will start to print again, and it will encase the part in, as long as it is flush with the current printing level, so the print head won't knock it. We have seen some customers that have accidentally hit the print heads, but it is a bit of an art. But those people that are doing it very, very well, and are embedding chips, RFID indicators, even wear pads is a good example as well within the parts on there as well. So you can see this pause after function here is very useful. So just going back, I'll just save that on the screen. So, and then I'll go back into the main view. So we've now added our part. We've added the continuous fibres to the part. We're happy with that. We can go back into the part view. You can see from the screen over on the left-hand side, it's telling me the dimensions of the STL file. It's telling me my print time, which is pretty much accurate, given, I would say, given kind of 20 to 30 minutes. It's giving you the print times, it's giving you the mass, the plastic volume used, the fibre volume used, and then the cost of your part to print as well. It is also worth noting on the internal view, as I step through the part, if you can just look at the top left-hand part of the screen, you will see that's telling me I'm 1 hour 36 into a 4 hour 54 print, and that my material cost up to that point is $1.78 out of $6.48 as I step through, and then that will change as I go through the software, telling me how much I'm up to in terms of material value on the part. So going back to the library on there, so you can set up your project folders, etc. You can set up different materials in the machine. So you can see this one here is printing in stainless steel. I've got this one here, which is in Kevlar. Again, a cube here, which is just in stainless steel as well. So we can go in. So if I just wanted to print this cube from the Metal X machine and move it back over to print in Onyx, it's just a case of one click, save that, and then that's my part moved from metal to Onyx, and it is as simple as doing that the other way. I can change my part from Onyx back through to stainless steel. You will see it's highlighted which furnace I'm using, which machine I'm using. I would save that, and then it moves it from composite back into the metal part as well. So it is a very straightforward process, switching machines around. Just wait till that saves. Okay, so going back into the software, it does have very nice dashboard functionality as well. So if I go to account settings and I go to dashboards, you can see here on the screen that we are showing the dashboards that we've got. So we've got here the number of users internally at Additive-X that are using the 3D printers. So they're all the engineers, the number of devices I have linked to the Eiger software, and the number of parts that we've currently printed on those machines. We then can have a look at that by different intervals of weeks, months, quarters, yearlies, on by the users as well. And then we can also look at that by the different materials we've used in different weeks and months, etc. So I can switch my material to all plastics, nylon, Onyx FR. So as a management tool or as a traceability tool, we can see which parts are being printed, which materials we're using more of, which engineers are using the machines and for what materials they are using them for, etc. And then all of that material data can be viewed, and then we can also download all of that as a CSV file if we wanted to as well, which would export it, and then it can be used to either report back to customers or report back internally, especially when we start to look at the return and investment about the machines. So if I go back to the library, so a question we're often asked is about putting parts onto builds. Can we nest parts onto the same build platform? Absolutely, yes, we can, as long as it's the same material. So for example, I could put on a part that just printed in Onyx on the same platform as a part that is printed in Onyx and Kevlar. What I can't do is an Onyx and Kevlar part on the same platform as an Onyx and Carbon Fibre part. So it's got to be the same continuous composite material on the build platform. So I'm just going to show you some builds here, and you will see there, so this is quite a nice one for a generic calibration test for a customer who wanted to assess the parts or the accuracy of the printer. So they sent us over all of these generic printed parts. We've loaded the STL files, we've set the parameters, and then we have printed all of those on the same print bed. They don't have to be the same part you print, as you can see, all the time, but they do have to be the same material subsets, so I say the Kevlar or carbon fibre, etc. But what was nice is all of those all printed. It took actually looking at the machine logs, which I was looking at the other day for the customer, it actually took 2 hours more than the machine had said it did for all of those parts. So we were actually up to about 40 or 50 hours worth of printing, and to print all of those only cost us $44 or $43.50 in materials. So that's how we moved from the build of the STL file on Eiger through to the main build, and it's a case of just then deciding you want to print your part. So if I go back into the main library, I go back into the motorcycle gear, so I'm all happy with that. I want to do that, I would just press print, and then it would take me to the build screen, and then I can either add multiples of the same part, or I can bring parts in from other screens or other Eiger platform into that same build. So very, very simple to use on that front. So I'm just going to pause the screen and go back to my main presentation, if that's okay. Carl, can you confirm you can see that all right?
I can, yep.
Lovely. Okay, so back onto the presentation. Oh, it's taking me right to the start. Bear with me. So now we'll.
Kevin, I think you might be paused again because the
there we go. Yeah, customer success stories.
Yeah, perfect.
Yeah. So we're going to. I'm going to run through some of the applications that the MarkForged printers are used for. If you do have, if any of the people listening do have the time, then it's well worth a visit to the MarkForged additive trends web page. So if you just type in MarkForged Additive Trends Report, it'll take you to this page. It is one of the best resources I've come across for applications by either the MarkForged materials, the application, or the industry. It really is a bit of an eye-opener when people start to look through it, because a lot of engineering companies tend to be able to see something that correlates or relates to what they're doing, and they think, my word, yeah, okay, we could look at printing that. It is a really, really good tool, and I would advise anybody on the webinar to spend 5-10 minutes just having a flick around that website and having a look at it. Just a bit of a kind of a note on the back of that: it doesn't work great on Google Chrome for some reason. So if you are wanting to look at it, please go through Internet Explorer. It has been reported to MarkForged that it doesn't work on Google Chrome, but yeah, it's better viewed on the Internet Explorer pages. But please have a look at that as a resource when anybody's got 5-10 minutes just to sit and do that. So you will see from that page that the Wartzilla piston lifting tool. We've actually printed one of these out internally because it is such a nice case study. So Wartzilla, based over in Finland, actually they repair and refurbish the parts from ferries, so the cylinders on the engines. And the lifting tools that they were traditionally making needed the machine to move the lifting tool around, or 2 or 3 people, and they've printed it, and they have reportedly saved thousands of pounds, especially when they start looking at the ability for one person to be able to just walk over, pick this tool off the shelf, bring it back, attach it to the part that needs to be lifted, and then moved around, and the price of making that particular tool as well. So I was talking about earlier about reducing the material requirement in parts. So obviously you can see here that they've taken the center out because it just wasn't needed. They've got continuous fibers running all the way around the parts, and in the different in the different axes, they've got different fibers running around. They can replace the lifting section very easily on here, depending on what they're picking up. And this tool has been certified by Bureau Veritas to lift, I think it was 960 kilo on there. So really is a heavy duty part for lifting, way beyond what we would be able to achieve just with standard plastics or polymers in 3D printing, and because of the use of continuous fibers within that. Where MarkForged really see massive benefits are on robotic arms and automation, be it cobots or manufacturing robots, etc. You'll see there that the tool is on the bottom. So this is from a company called Dixon Valves over in the US. You will see there they've highlighted the parts. So Dixon Valves have reported that they used the onyx material because it was non-marring on their product. Also, the fact that it could lift heavy parts because of continuous fiber. And you will see that they have reported the development time and the printing time of having tools made was 87% faster than the traditional methods from the machine shops. It's also freeing up a lot of machine shops to concentrate on customer orders, to concentrate on where the higher value goods may be, and freeing them up to do that. And you can move other parts onto the 3D printers, creating greater bandwidth in the machine shops for better utilization of time. But they've also reported that it's a 97% cost saving to them on this particular part as well. So they don't all have to be high level, high reaching applications. So these are some of our own that we've done with companies in the UK. So this company is a confectionery company. The part that was on the left, which is the red part, is a picking arm. They used to have these in sets of 2, and I believe it was around 8 or 9 sets on a picking cylinder. They investigated using 3D printing because that part was just over-engineered and too heavy for what it was picking up. And they started to look at how to reduce the weight on their line. I'll touch upon this a little bit further down, but also the ripple effect is important. What other benefits do 3D printing parts bring, or what can they bring? A massive benefit to this company is they were removing oil and grease from certain areas of the food production line. So we used Eiger, so Eigers, depending on how you want to pronounce it, non-grease bearings in the part. And you will see there, going back to the issue I mentioned earlier about the XY and the isotropic being on the XY and not the Z, all we've done is to strengthen up the Z axis on this particular part, is add in some strengthening bolts across the Z axis. So we designed the holes in, the strengthening bolts were added, and it was added to the area which we felt was under some pressure. It was clamped at this side. The continuous fibre ran around the picking arm, and then that left this part here, which was then strengthened on the Z using those strengthening bolts. So you can see obviously the weight difference on one of these parts was 340 for the original, 128 grams for the 3D printed part. And then we had a 62% weight saving, and then the company also had a cost saving on that part of £240 a set. They are still on those machines. They are working fine. They are performing beautifully, and yeah, the company have gone on to invest in multiple desktop 3D printers or MarkForged desktop 3D printers for their production lines. I believe what he has done, going back to that reporting tool, is that he has set up different builds on different lines, and he can export his data depending on what lines use the part. So if you can start to see which line is using potentially more parts than other lines and investigate why that. So he's using that as a line reporting tool as opposed to a user reporting tool. Just going to go to the next screen. This one, often when we show this part, which is the metal part in the middle on the top right, a lot of people nod and kind of have a little smile to themselves, and because think, yeah, I've seen something like that in my place of work. So this is from a pet food company who have a machine which is 30-year-old. My understanding is that it's a crimping machine to put the folds in the bags for when they're sewed across the top. As you can see from the image on that, the part kept breaking and it was welded. It broke again and it was fixed. They called us in to have a look at what could be done on the line, and this was one of the parts we identified. So you can see the part was redesigned. It was important to know what that was pulled back into so we could redesign that part. We managed to add continuous fibres throughout the design, and then again you will see in the bottom image, we would never recommend on plastic extrusion printing screw threads. They will shear no matter which printer you're using on plastic extrusion, and it won't have longevity. So we would either recommend using brass inserts, or if it's going to somewhere that requires them steel inserts, you're going to get better accuracy on the screw threads. They're going to be longer lasting, but because we're printing in a nylon and we can reinforce around that, the screw threads can either be heat inserted or just press fit. In these particular ones, we're just press fit in using a vise on there. So you can see we've redesigned the part. We have actually taken that one step further now, and the two screw threads you can see on the bottom of the part on the Z-axis are actually to hold the crimping tool itself. We are now just printing the full part with a crimping tool on the end, so it's just a straight one-piece replacement for the customer. Again, he can keep one on the shelf. If it does break, he just prints another one. He has his line up and running straight away, so he's moving towards digital inventory of parts, of having one in stock. So when we're doing stock takes, etc., you can imagine there's minimal counting, very easy to review. You're not holding loads of parts in stock, but as in his case, he wasn't holding any in stock because it was legacy parts. So it's all about the machine time and the uptime, or minimizing the downtime on that particular line. this is quite a nice example. So we spoke to this customer at length, and I've included it because it's kind of a little bit of an eye-opener when looking at additive manufacturing in general. So the customer was having an issue with parts breaking. Carl, if I move my mouse around, can you see the mouse on my screen or not?
I can.
Right. So it was breaking in this particular area here. So the stresses were coming in here and here, and it was snapping across this part. So they came to us, it was injection molded initially, and they came to us and said, how can you strengthen that part up for us? How can we start to look at changing the design of that part and strengthening it? So our initial kind of thought was, well, we will add composites, continuous composites into it, as you can see from the blue with the carbon fibre. Now, that didn't really work because I'm sure you can see where it's thinner and where it was breaking. We could only add one strand of carbon fibre into that. Now, the reason for that is that it needs to have a certain width of the part to be able to lay the composite in, come back round, and add a second curve in. It's around 2.9 or 3 mil on that, and their part was just too thin. So our applications engineers discussed with them at length, and the solution we came up with was that we designed some cavities, bottom left picture, into the part. Again, because no tooling is required, it's very easy to experiment with the 3D printing. So we designed the cavity into the part using diamond shapes, etc. So diamond shapes and teardrop shapes when looking at additive means that we can print or we can negate support structure. So we didn't have to remove anything out of that hole. We then bought some rods to go into that. And as you can see from the bottom right picture, the rods were inserted into the areas where we couldn't fit the continuous composite. So it was in to add a little bit of strength, but then we reinforced the part fully using both the inserts and the composite materials in there. And again, that worked brilliantly as a solution. The massive advantage of that is that he could experiment with that design because just no tooling was required at all. So he could put that on, test it, and it did work beautifully for him. So I'm just going to show this video as well. I do this is a kind of personal favorite of mine because you don't think a 3D part, printed part would be able to do this. It is in German, if anybody can hear the volume on that, so I do apologize, there's not an English version of it, but it does show a MarkForged part printed on a Mark II 3D printer using the white nylon and the continuous composite material. I believe this continuous composite was Kevlar that they used. But about a minute, it's just over 2 minutes long, or just under 2 minutes long, sorry. So you're seeing there the kinetic coupling on the Mark II print beds. Again, it just shows the strength that the MarkForged parts can achieve with the continuous fibers. So we do have some customers, unfortunately I can't go into too much detail on it, but we do have customers making lifting tools and lifting jigs with the MarkForged units at the moment, and they are getting some absolutely fantastic results, and some of the figures they are putting out for cost savings are phenomenal. The customer has purchased 2 of the X7 3D printers to continue their drive into it, and hopefully the plan moving forward will be that those parts can be printed throughout the world by just sending a MarkForged file, which is then locked down, so it can't be altered, and then it can just be printed anywhere globally because they've got the right settings, the file's locked down, the material, the tool paths of the composite is locked down as well. So it's just a case of downloading a file and pressing print on that particular machine. Some hybrid tooling, I mentioned this earlier. There is a demand for this is growing. I wouldn't say it's massive at the moment, but it is absolutely growing, and interest is starting to get there with hybrid tooling. So we've got a Metal-X 3D printer and the composite machines, as has the SAM project, and we printed this gear. So you can see again, top right hand corner, we've got the inner and outer of the cog, and then on the bottom picture you can see we've printed the inner with composite materials. We did add some continuous fibre just around the outer track of that, just to give it some additional strength. But the weight saving between the parts, if we printed it in a solid metal or it was machined in a solid metal, versus printing the inners and outers and then printing the inner as a composite, was brilliant and was a great weight saving. We've started working on a customer with this, but what we were really delighted about was both parts were taken, or 3 parts if we include 2 metal. The 3 parts were taken off the printers, absolutely no post-processing done to them whatsoever, and they're fitted together first time. Our CAD designer internally is taking the credit for that, but it just goes to show the accuracy of the machines and swapping between the Eiger platforms. The fact that we can take a composite part and insert that straight into into 2 metal 3D printed parts was fantastic. So again, we do have these parts on shore at our facility in Ripon, and I think I've shared the files with Carl as well, but I can they're not proprietary. We did these ourselves, so we can share them if anybody is interested in those files. So just a little bit about return on investment. Where we rarely win is if we are just comparing part cost versus part cost. Many people come to us and tell us, I've got this part injection molded and I can get it for 12 pence, whereas we can't possibly print it for that price. What we do need to take into account, and what we start to go on a bit of a journey with customers about taking into account, is that part really is not just 12p. You've had to buy them in a quantity. You have to stock that part. You've had to pay for the molds or the tools for that part as well to get it at a 12 pence price point. You've then got to store that part, as I say, for things like stock control, warehousing space, etc. We can then start to have the conversation about supply chain. We can bring your supply chain off of making of parts on the lines, if you do have a production line, to within meters of where it's going to be used. You're not shipping parts around the world, especially with the likes of Brexit just being coming in as easy as the government have said it's going to be. I'm sure any industry partners out there will appreciate it is causing issues with logistics coming into the country with tariff codes and etc. and paperwork coming in. That's not the case. You can just print a part and have it straight away in your inventory. Lots of people are using digital online inventory. As I mentioned before, it's ideal if you've got a company even just down the south of England, or if you've got a company in mainland Europe or the US, you can design a part, or they can design a part, the files can be transmitted, you can print that part without any delay whatsoever and have it in hand ready within a couple of hours or a couple of days, depending on the size of that part. Operator costs for the 3D printers are minimal. They will run by themselves. Yes, training will need to be given up front, but you do not have to stand over them and watch them. They can they are lights out manufacturing. So we try to build all of that into the conversation about how are you getting parts made at the moment, and what are those associated costs of making, receiving, ordering and delivering those parts around the place as well. Plus, because of the continuous fibres, we can now make parts that are immensely strong, and as I mentioned at the start of the presentation, are replacing Delrin and aluminium in many cases as well. So conclusion, because I think I'm coming up to my time. So the additive manufacturing, it is reaching a tipping point, or I would say it's there where price points for companies, they can afford the technology, especially with the likes of the grants from the SAM project, and working with the likes of the SAM project to look at the viability of that, or working with ourselves if you're out of the SAM project, so LEP region. We always advocate manufacturing as part of your company toolkit. It doesn't replace CNC machining, it complements it. There are parts that CNC machining can do quicker and cheaper than we can, and there are parts that we can do differently, better and quicker and cheaper than CNC machining can. So there is a trade-off, and it's got to be the right tool for the right job. We absolutely are advocates of that. The interest in additive manufacturing technologies has increased over 2020 due to the pandemic. Initially, it was printing the visors for PPE equipment that had a big spike, but then as supply chains were disrupted longer than people were expecting them to be, and now because of Brexit, we are getting a lot of people coming to us saying, I really need to look at this. I was meant to look at it a while ago, and due to being busy, we never got around to it, but it's got to the stage now where we need to look at it. So again, if that's the case, SAM project or ourselves are here if you're out of their region to discuss additive, redesigning products so they can work better. The part I showed you initially on the Eiger screen, not the one that I added the fibres in, but there is a part that Stanley Black & Decker have made, and it just works more efficiently because of the way it's been designed due to 3D printing, and it couldn't be machined any other way. If I just very quickly flick back, it's this part. It can't be CNC machined because the channel runs all the way through it. It's printed in one piece, and because of how it's used, it's more efficient for them. So you can generally rip up the rule book and go with the way you rip up the rule book and how parts were designed, and start again on some of those parts, and then legacy parts as well. So a lot of companies have old machines. You need to keep them up and running. Absolutely, 3D printing is perfect for that. So MarkForged are looking at developing the Eiger software. The machines are updated regularly. In fact, there was a firmware update last night as I was doing this presentation. One popped up on the Eiger software to update certain aspects of the MarkForged printers. So they constantly are updating and looking at how to improve the tolerances of their parts. And as I mentioned before, the improved surface quality finish, the MarkForged are by far the best we've seen in the polymer extrusion market, coupled with the fact they can do high strength parts. They are really fantastic. I've just put down there the continuous composite range runs from 7,765 for a machine that can use onyx and fiberglass, right the way up to the X7, which can use absolutely anything on that. Samples are available. If anyone wants to go through the SAM project to request that, we can send the samples out. My email address is there if anybody wanted to take that down. Again, this presentation is downloadable from the handout slides as well, so it's all on there. I hope it's been of some use to people, and that's been of interest. If there is any questions, more than happy to answer that, and thank you for attending and signing in and listening.
Thank you very much, Kevin. That was a really interesting presentation and gave sort of a really good overview of how that how this technology can be used. I'm just going to take this back, show the screen. Go. So I'll put my camera back on so you can see me and Roger. So we've got a little bit of time now for questions. If anybody wants, there should be a section on the GoToWebinar where questions can be asked. Got a couple just want to go through with Kevin now. So when using the Eiger software, and it had the pricing that was going to be used. where's that pricing from? Because that was in dollars. So how does that translate to the kind of UK pricing?
So you would, I mean, the pricing is, it's taken, MarkForged load the cost of their materials, RRP price into the software, and that's taken us into the centimetre cubed or grams, depending on how they work it out, of material used. It's a direct correlation. So when we're talking to customers, to give a ballpark figure, if it's $6, we would just do a direct conversion from USD to GBP as a bit of a manual process. So, I mean, my phone has got a currency converter on it. So when I am talking to customers, literally I would just type in sort of the $6.43, I think I mentioned, just correlates directly to £4.70. So unfortunately, because they're dealing in so many countries, they haven't changed the Eiger software for local currencies. So everything is driven, because they're an American company, it's all just driven by US dollars on the software.
Yeah. And another question about the different fibre types. So there's the Kevlar glass fibre, carbon fibre, and the high strength glass fibre. Could you give us sort of an overview of kind of the what would inform your choices about which fibre to use?
So it's all about the application, if I'm honest with you. So we've got some customers who, if it's real high strength application, then carbon fibre is by far the strongest material. What we've got to consider is it going to be a part which is moving around? So does it have inertia? Does it have impact, etc.? So it's all rail driven. So a nice example is we were talking to a customer. It was in November time, who wanted to hang a piece of camera equipment from a MarkForged jig or holding, and because that camera was swinging around and suddenly coming to a stop very quickly, then the carbon fibre was no good, because it's a single fibre strand, and if it stops quickly and the part underneath has any inertia to it, it's liable to snap the carbon fibre, or more liable to break the internal carbon fibre strands. So looking at something like that, you would look at something like Kevlar, because it's a twisted fibre rather than a single strand. So Kevlar can absorb that impact better, but still give strength. So it's really application driven. And when we talk to customers, we want to know a lot about application. Where is it being used? How is it being used? Sometimes we just say, we are honest and we say, well, that application, we've got no direct correlation across, but our understanding would be that this would be your best material. But MarkForged again laid out, they recommend, I say, Kevlar for impact resistancy, fiberglass for like a nice halfway house between for strength and cost, because fiberglass is the cheapest material. So if you just want some strength but you don't need the strength of carbon fibre, fiberglass is ideal. Again, a twisted strand, so it does carry some impact, but not as much as Kevlar. And the high strength, high temp fiberglass, we tend to use that for parts which are very, very close to the heat deflection temperature of the material. It just gives it an extra bit of resilience in there as well. So for anything that people are molding, so we've had companies that are doing, they're printing the parts and are wanting to do injection molding over the top of them. So we would use that in that kind of application as well on that, be it for tooling for those molds, etc. I hope that's answered a bit of that question.
Yeah, totally. In terms of high temp, because that's sort of means the high temperature is going to mean different things to different people. What sort of temperature range are you talking about?
So the onyx material goes up to about 145. Now, bearing in mind that the onyx is the outer matrix materials, we wouldn't recommend going kind of over that. But what the high strength, high temp fiberglass does do is it gives the internal of that part a bit more resilience. If you have the walls to two passes, so 0.8 mil of a thickness round, it will add some resistance against that under the 0.8 of a mil. So we've used this for injection I keep saying injection molding, not injection molding, for thermal forming over. it does work brilliantly. So we would use that when it's starting, customers are starting to talk about 130, 140 temperatures, then the high strength, high temp fiberglass, we say,
Yeah.
well, it would assist that application.
Yeah, with when I've talked to some clients, sort of thinking more about sort of inside an engine bay rather than sort of inside a furnace. So people get excited to say like high temperature, and it's like, well, high temperature.
High temperature for my polymer world, yeah.
Yeah.
When most of the materials like PLA, etc., sit around, depending on the variant you're using, between 45 and 60. Yes, if it's higher than that, we would need to look at peak, but then we lose, unfortunately, from MarkForged, they don't do peak. But as I mentioned at the beginning of the presentation, that's got to be an area they're investigating. They don't tell us their product roadmap, but it's absolutely their playground. It's absolutely their kind of sweet spot, high strength, and usually with high strength conversation, it comes along high temperature. So it's got to be an area they're investigating.
Yeah, with I mean, there's a couple of really interesting kind of polymers that came on for the X series, which the ESD safe and the fire resistant materials. I think they're both really interesting in terms of their kind of usage. And again, it's pushing this polymer additive manufacture kind of beyond that sort of like toy or prototype into sort of making functional part. So it is really interesting.
Yeah, absolutely. I mean, they see the ESD material being used on PCB production lines, etc. For moving, I suppose they're called mini pallets, moving around the PCBs for that kind of application, or anything that is, as everyone will know, just housing electronics. Being totally open and honest with people, what MarkForged don't have for the flame retardancy and why they can't use them for flight certification is the material traceability yet on the materials. So whilst it's certified V0 rated and it has a blue card certification to be used with the X series machines, it doesn't have full material traceability back. So I had a long conversation with a customer over Christmas. It was quite nice because we had time to look into it for him. It was all about the UL and UR certification. So UL labs and UR ratings, it doesn't carry that because of that traceability.
Is that coming? Do you know? Or?
Do you know what? I spoke to the MarkForged applications engineers, and they said to me, "Yes, we know that's a requirement, and we have raised it internally." I can only take that as it's been discussed and worked on internally. But they won't kind of release any information till it's pretty much ready to be kind of released and the materials ready. Interestingly enough, it's the MarkForged Global Partners Summit this week. It started yesterday afternoon and runs today and tomorrow. And it's usually where they start to make some announcements about products. So it may be that something is announced over their Global Partner Summit this week.
Yeah. I just mentioned something like kind of briefly touched on in the presentation with the blacksmith software. I mean, I think this is something which we get asked. One of the first questions people ask us is about sort of part accuracy, and I think that's a really interesting sort of roadmap that MarkForged is looking at, where your parts can be scanned after they've printed, and then the software which will kind of test that against the CAD and then can allow you to print sort of a corrected version.
Yeah, so I mean it's still very much in development. What they are doing is they're working with MSC software and is it Faro scanning arms?
No, oh yeah, actually they are working with
the Faro scanning. So yeah,
MSC is owned by Hexagon, who makes scanners, but then
which is
the Faro scanning arms,
which is ironic because they're using the Faro scanning arm technology. But MSC software with Faro arm technology, and it's all about getting the combined AI feedback. So what they're doing is, or what the idea behind it all would be that customers can scan parts, feedback the geometry into the software, into this blacksmith software, and blacksmith will learn from the geometry of a part, and then we'll be able to tighten that part up for the next print, but also take that back into a wider AI learning and look at other geometries of similar parts and tighten those up. It's not there yet, but that is their idea, to get away from the question about how accurate are the 3D printers. They want to make them it kind of as accurate as a CNC machining tool. So it understands how it works on curves. It understands how it works on certain geometries of parts, and it's all done by this artificial intelligent communal feedback.
Yeah, so I was looking at something kind of recently about that, and this is apparently MarkForged been kind of using this Eiger software. It's been developed from very early days for their internal testing to continually improve their part accuracy. So it'll be fantastic when that's kind of released. I think in the meantime, though, I think we both came across the same video recently that's looking at something which MSC Software is kind of who partnered with MarkForged, looking at analysis, FEE analysis of the parts using kind of Digimat software, which is from Extreme, which is also owned by Hexagon. And this, I think, is something is really interesting in terms of it allows you to output sort of the paths from the printer as they would be laid down, and with adaptations to actually where the plastic and the fibre reinforcement is going to be laid down, because the fibre reinforcement is sort of ironed into that. It's almost like the strands are almost like a pre-preg that are kind of laid in, and that so it knows this software can export where the fibre is going to be laid, where the plastic's going to be laid, what direction it's laid in, and that can be then kind of fed into sort of a higher end analysis software, so like Nastran, to come up with some analysis to show you sort of exactly how strong a part is going to be, and looking at their sort of test results compared to the simulated results compared to the real world results. They sort of correlate really closely. So I think that's something I'm really interested in, because it's one of those, at the moment, it's like kind of knowing exactly how strong something's going to be, how much of fibre is going to add, because something like the carbon fibre to add does increase the cost, and if you put a load in it, it really increases the cost. So if you're making a one-off part, it doesn't really kind of have a huge impact. But if you were looking at this to replace, let's say end effectors for something, and you wanted multiples of them, then that saving could be kind of quite significant. So it's something that, I think certainly to look at. I mean, I think you were saying that functionality may be rolled into different tiers of Eiger kind of later on.
So I mean, we've had no kind of, we've seen videos online. There's been no official announcement, so that's why there's not been a lot of kind of shouting about it. But you're quite right. So barriers to entry are questions: will it work? Will my application work? Will that part suit my application? And the answer at the moment is, as I said in the presentation, we've got to draw on our knowledge. We've got to draw on previous case studies or examples, and also applications engineers. But this software, I hope, will be a game changer in terms of negating those kind of questions. Now, yes, you're quite right. I can see it being rolled into Eiger as it stands. Cloud-based is free of charge, but this software is not cheap, which I'm sure you'll appreciate. So it'll be rolled into, I think, subscription tiers of Eiger. We've no timeline for when it's due out. It's not really been widely discussed with the channel other than the videos that they've dribbled out and then pointed us to. So we're not selling machines on the back of this is coming, but absolutely, again, it's one of those areas which MarkForged are well aware are a block to selling, to be blunt, and a block to using, and a block to moving the additive manufacturing market from where it is now to absolutely going stratospheric, because people then have faith in that product will do that part and will do it right, because we've done all of the analysis, and that's the key to unlocking those larger lifting tools, to getting in to all of that, because at the moment some of the larger companies have got the benefit of experimenting. They've got the benefit of they've got their R&D teams. They've got money they can do that with Bureau Veritas, etc. But if you can have that FEA analysis and it kind of rubber seals it, absolutely, that's going to be fantastic for everyone.
I mean, I think there'll still be absolutely a role for doing some physical testing of the parts, especially for something that's part of a lifting system. But I think to cut down the number of iterations, so you can get sort of your best guess of, or not your best guess, your best sort of engineered part for what's going to be kind of correct from the start, and to verify that through the physical testing rather than, you know, going through multiple systems.
It gives you a line in the sand to start with, doesn't it?
Yeah, I mean, perhaps, I mean, that's something I'll pick this up with kind of Roger afterwards, but you know, kind of, we could perhaps approach, so we've got links with MSC software, and it's perhaps something we could kind of pick up for a webinar in the future, because I think it is, in terms of industrial uses, it is that sort of missing bit of the jigsaw at the moment. I've got a question from Julian McBride, who's asking, is it possible to combine features printed in metal within composite areas, or would they need to be printed separately and assembled?
Separately and assembled.
Yeah, I mean, they're two, Julian. They're two different printers. The Metal-X, Metal-X kind of it's almost like a metal injection molding system. So it will print. So it works like an FFF or FDM printer. It'll print almost like a wax material with metal powders impregnated into that. That then goes through a wash system and a solvent to remove a significant amount of that wax material, leaving quite sort of a porous open structure part. And then that part goes through a sintering process where the rest of that wax bind is burnt off, and the metallic powders which is left are sintered together to form that kind of part. When we're looking at sort of assemblies, then it's different systems, so you can print them and then combine them later. I've got a question from Nicola Haynes. Are we speaking about the cost of blacksmith software or the cost of MS software used with Faro scanning? I
don't have any cost on that.
Yeah, don't know the costs of the blacksmith yet, because it hasn't been. It's in a closed sort of alpha testing at the moment. So don't know. Kevin, do you know, because there is a sort of an offline version of Eiger, Joe running it on the cloud at the moment. So sort of, do you know the cost of the offline?
Yeah, so the offline version of Eiger is a couple of generations behind the online version, because it's obviously not updated as regularly. It's £4,000 to buy an offline version of Eiger. Now, there's no subscription package after that as such. But, for example, if you owned an X7 and MarkForged bought an Onyx ESD material out, and you bought Eiger 2 years ago offline, you would need to pay, it's $1,000 US to buy the new version of it, which has the ESD material availability on it, if that makes sense. So you buy it as you would need the upgrades. So if you don't need ESD material, you don't need to buy the £1,000 or $1,000 version upgrade. So it makes
sense for Mark. That makes sense for MarkForged, perhaps.
Yeah, I mean, it ideally, we understand some companies can't use web software, cloud software, but the vast majority can. The vast majority are using some form of cloud software in the business anyway. But yeah, we absolutely get it. MarkForged get it, but their offline version is £4,000.
Yeah, in terms of the MSC software, you'd need to speak to sort of an MSC kind of representative about that. But I know that, I mean, their Nastran and Patran FEA software has a significant cost attached to it, because it's a high end sort of piece of kit, you know. But again, you need to speak to MSC to talk about pricing.
Yeah, well, I mean, the Eiger cloud version is brilliant for what it needs to do to control the machines. It's
yeah. I mean, I think if that functionality could be built within Eiger, I mean, that would be sort of amazing, because the process of kind of it's not a simple task to kind of set up an FEA system.
No, I'm sure that's the idea moving forward, and that's where you'll get the tiered subscription services coming in.
And the question, why do you believe blacksmith is best for you? Well, I think it's a bit of an unknown at the moment, because we've just seen some like kind of videos of it. But in terms of what the blacksmith can do, so we've talked about the accuracy of the MarkForged system, and I must say, I mean, I run sort of half a dozen different types of machine in here, and I've used lots of different FDM machines in the past, and nothing has come close to the MarkForged systems in terms of like surface quality and accuracy. So the accuracy is really good, but it is, at the end of the day, sort of that fused filament fabrication process. So it isn't the same as sort of a machined part. So there can be some warpage that happens during the kind of printing, because you're printing with a very hot material, and that's cooling as other parts are still being kind of deposited. So what the blacksmith can do is that it can compare the printed part to the CAD part. So say if you had something that would say this kind of part, which I had kind of, you know, it's a metal part that's being printed on our MarkForged printer. But say you wanted this part to be printed, but actually it was printing with, perhaps there's some issues around cooling, say, and these bosses were sort of slightly raised. As it's being demonstrated in the blacksmith, the scan would indicate that there was an error, and it could offer to sort of produce a corrected model, but they were deflected the other way. So you could then reprint that, and then that compensated part should deflect back to straight. You could then scan that again, test it, and repeat until you get a sort of that accurate part. Now, for one-off parts, then that's, you know, that perhaps isn't going to be the best system. But people are using these in terms of making end-use parts. So if you're going to be making kind of multiple, like thousands or hundreds of these, then to automate that process of kind of getting that file nailed and kind of correct the first time is could be really useful, compared to sort of what we do at the moment. Kind of that's a manual kind of process. We'll get something, we'll look at, we've got hexagon scanning arms and probing arms here, and we can kind of look at, we can check the accuracy of something, and if needed, we can kind of manually kind of alter the CAD to do that. I must say, it's not something we've particularly needed to do kind of huge amount for MarkForged systems, but I think it's very interesting setup.
Yeah, As you said, the blacksmith software is going to be good when it's out, as is the other software. But it's just not there yet. But MarkForged are well aware that this is something they need to be looking at. But as it stands, yeah, it's just not there yet. So it's down to experience. It's down to talking to people like yourselves, and any reputable value-added reseller will be able to have those conversations with the customer as well.
Yeah, in terms of the analysis, the MSC and Digimat software that is available now. So that it's So if somebody had a kind of question about needing some part verified for strength, that is something that could be looked at. So how are we doing for time? I think we've got 5 minutes. So any kind of final kind of questions, or Roger, have you got anything to add?
No, really. I've just obviously drawn some of the benefits that some of our own SAM clients have seen from working with us, using 3D printing, additive manufacturing to support traditional manufacturing, not necessarily as even replacement parts, but as fixtures or manufacturing aids as well, which has facilitated quite a bit of investment. So we've had 3 or 4 companies now have gone through the grant process, having done a technical project with us to see the benefit. One was a traditional machine tooling company, and they were producing large machine parts for them. And I know you know the story very well, Carl, because he was closely involved with it. They were having to do extra operations on additional machines, but by using some 3D printing to print fixtures, they were able to reorientate the parts and keep it on the one machine very quickly, cost effectively, and that made them decide to invest in it themselves. So there's all those examples that we're seeing. Likewise, we've seen other examples of assembly fixturing manufacturers and facility manufacturers who are using it to print simple parts. Some of it are simple parts, some of it are quite complex parts that otherwise they would have to be buy-in or machine, and it just speeds their whole process up and gives them that increased flexibility. So some good examples there. Obviously, we'd encourage people to come in and talk to us, have a discussion, and see if we can help them. As I say, likewise in the handout section, there's the information on the SAM project, and as well you can go through to the SAM website and find more information there as well. So if you're an SME, so a manufacturing SME, then you're eligible for the SAM project. Even if you're outside of the northeast left area, you may still be eligible for SAM support if there isn't an equivalent project running in your local LEP area. So we can support through that.
Sorry, I've got feedback from something there. Well, thanks very much. I must apologise for starting a little bit earlier than intended. So if anybody missed the start of the webinar, it has been recorded, and an email will come out, be sent around to everyone who registered over the next couple of days with a link to where that can be downloaded from. And as it's been said, there's handouts that are available. They'll have some PDFs looking at the materials and the specs of the MarkForged systems, and the SAM. There's PowerPoint of the SAM deck, and also the PowerPoint from Kevin from the MarkForged. So I think we are bang on time almost. Okay, well, Kevin, thank you very much again. It's really interesting.
Pleasure, thank you for the invite.
No problem. Okay, and thanks everybody for attending. Okay, thank you. Goodbye.
Thank you.
Yes, thanks everybody.
Bye.
Good luck, guys.